All right, so now taking care of branch instructions. So you should see that your program is executing properly up to the first branch, but it's, the PC is continuing to march onward. So there are two signals that we need to hook up to steer the branch appropriately. This is a conditional branch instruction. It's going to branch on a comparison condition. So we have a register that's got a value of 10 that's indicating how many values we're summing up, and then we have the register that's counting up to 10. And as long as that count is less than the register with 10, is less than the 10 value, we're going to take the branch and do another iteration of the loop. Otherwise, we want to fall through and continue execution sequentially. So first we need to determine whether the branch is taken, and we're only supporting the BLT instruction, so we'll only do this for the BLT instruction. So we have a signal called taken branch, taken BR, that you're going to come up with a logic expression for, and we want that signal to assert for BLT instructions where the source 1 value is less than the source 2 value. So go ahead and come up with a logic expression to do that, and assign taken branch, and then come back and we'll finish up with the branch target calculation. All right, so now the branch target calculation, we need to know if we are taking a branch, where are we branching to? And that's determined by this BR target PC signal. That signal is not currently assigned. You're going to create this adder here, but it is looped back to the program counter and used to update the program counter. So as soon as we assign this signal properly, we'll branch to the right place. So the right branch target is determined by as I said, the immediate value is providing the offset for the branch target, offset relative to the program counter. So you want to add the program counter to the immediate value, and that's your branch target. So go ahead and provide the expression for the branch target PC. And at this point, if everything is hooked up properly, you will actually see that your simulation passes. So if you look in your log, you should see this simulation passed message. If you don't, figure out what's going wrong, right? Step through, start out with the visualization, see where the visualization goes south, isn't doing the right thing. That might give you a hint as to what logic is broken and needs to be fixed. If you can't figure it out from that, you might have to, once you see the overall behavior that's not quite right, that will give you a hint where to dig into the waveform. You can use the logic diagram to help understand what logic is producing values that aren't behaving properly, and use the waveform to see those values. So debug as needed. Hopefully you'll be able to come up with a working simulation, and then come back when you're finished that.